We've been talking for the last couple of months about the results from an analysis into EBVs as part of the lessons from the Angus sire benchmarking program. EBVs are a powerful tool for modern cattle breeding programs, and the work has given some great insight into not only how accurate they are at predicting progeny performance, but also how they respond to new information coming into the analysis. There's a significant amount of variation between animals within the Angus population, and this variation presents a lot of opportunity to improve the productivity of Angus beef enterprises by utilising better genetics. To examine this variation, we looked at the sires within cohorts 1, 2 and 3, and then as a separate piece of work cohorts 5, 6 and 7 of the ASBP. We took the 5 sires within each cohort with the highest performing progeny average and the 5 with the lowest progeny performance average and compared the difference. EBVs move as more data comes into the EBVs calculation, and this can be from a number of sources. Progeny performance information is one of those sources, and a recent piece of work examining how much did the EBVs of sires in the ASBP change with the inclusion of their progeny performance information. How well did EBVs of bulls entered into the ASBP predict the performance of their progeny for growth traits was part of 2 pieces of work which examined cohorts 1, 2, 3, 5, 6 and 7 of the ASBP. In order to examine this claim, we identified the 10 sires for each cohort with the highest EBV for each trait and calculated their average EBV, and then repeated this same process for the bulls with the lowest EBVs. We were then able to identify the expected difference by halving the EBV difference between the average performance of the progeny by these 2 groups of bulls for each of the traits. We then went and looked at the performance of the progeny by these bulls, which enabled us to answer the question based on the difference in the top and bottom 10 bulls for each of the traits. An actual average difference of 8.6, 14.2 and 19.9 was recorded for 200, 400 and 600 day weight of the progeny, highlighting that EBVs reliably predict the performance of progeny for growth traits. Carcass traits are regarded as hard to measure traits, and one of the advantages of EBVs is that they give us an insight into the trait in live animals. So how well do EBVs predict the carcass composition of animals? So 2 separate pieces of work have examined this approach across 6 cohorts of the ASBP, representing 243 bulls and their progeny. The results found that across the cohorts for birth and fertility traits, the EBVs accurately predicted the performance of the progeny. The resources developed as part of the lessons from the Angus sire benchmarking program are a great resource to have and use. Whether questions come about how accurate EBVs are at predicting progeny, the potential to make further gains within Angus breeding programs, or if we want to better understand how EBVs move as more information comes in, the resources are now available and they build on earlier work to provide a comprehensive response to questions raised around EBVs and demonstrate EBVs reliably predict progeny performance. Check out the resources by visiting the Angus Australia website. Under the sire benchmarking tab, select one of the resources.